Stat system call. Stat is a Unix system call that returns file attributes about an inode. The semantics of stat vary between operating systems. As an example, Unix command ls uses this system call to retrieve information on files that includes atime time of last access lslu, 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 mtime time of last modification lsl, ctime time of last status change ls lcstat appeared in version 1 Unix. It is among the few original Unix system calls to change, with version 4's addition of group permissions and larger file size. Stat functions. The C POSIX library header sys/stat h found on POSIX and other Unix-like operating systems declares the stat functions, as well as related functions called fstat and lstat. The functions take a struct stat buffer argument, which is used to return the file attributes. On success, the functions return 0, and on error, 1 is returned and no is set appropriately. The stat and lstat functions take a file name argument. If the file is a symbolic link, stat returns attributes of the eventual target of the link, while lstat returns attributes of the link itself. The fstat function takes a file descriptor argument instead and returns attributes of the file that it identifies. The family of functions was extended to implement large file support. Functions named stat64, lstat64, and stat64 return attributes in a struct stat64 structure, which represents file sizes with a 64-bit type, allowing the functions to work on files 2 GB and larger up to 8 IB. When the file offset bits macro is defined to 64, these 64-bit functions are available under the original names. The functions are defined as stat structure. This structure is defined in sys/stat h header file as follows, although implementations are free to define additional fields. POSIX 1 does not require int_rdev, int_blocks, and int_blk size members. These fields are defined as part of XSI option in the single Unix specification. In older versions of POSIX 1 standard, the time-related fields were defined as int_atime. Since the 2008 version of the standard, these fields were renamed to int_atime, int_mtime, and int_ctime, respectively, of type struct time spec, since this structure provides a higher resolution time unit. For the sake of compatibility, implementations can define the old names in terms of the tvsec member of struct time spec. For example, int_atime can be defined as int_atime, tvsec. The struct stat structure includes at least the following members. The int mode field is a bit field. It combines the file access modes and also indicates any special file type. There are many macros to work with the different mode flags and file types. Criticism of atime. Reading a file changes its atime, eventually requiring a disk write, which has been criticized as it is inconsistent with a read-only file system. File system cache may significantly reduce this activity to 1 disk write per cache flush. Linux kernel developer Ingo Molnar publicly criticized the concept and performance impact of atime in 2007, and in 2009. The relatime mount option had become the default, which addresses this criticism. The behavior behind the relatime mount option offers sufficient performance for most purposes and should not break any significant applications, as it has been extensively discussed. Initially, relatime only updated atime if atime mtime or atime ctime, that was subsequently modified to update atimes that were 24 hours old or older, so that tmpwatch and Debian's popularity counter Popin would behave properly. Current versions of the Linux kernel support 4 mount options, which can be specified in fstab. Strictatime, formerly atime, and formerly the default, strictatime as of 2.6. 30 always update atime, which conforms to the behavior defined by POSIX. Relatime relative atime, introduced in 2.6. 20 and the default as of 2.6. 30 only update atime under certain circumstances, if the previous atime is older than the mtime or ctime, or the previous atime is over 24 hours in the past. Not or atime never update atime of directories, but do update atime of other files. No time never update atime of any file or directory implies not or atime, highest performance but least compatible. Time update atime according to specific circumstances laid out below. Current versions of Linux, Mac OS, Solaris, FreeBSD, and NetBSD support a no-time mount option in /etc/s tab, which causes the atime field never to be updated. Turning off atime updating breaks POSIX compliance, and some applications, such as inbox-driven new mail notifications, and some file usage watching utilities, notably TMPWatch. The no-time option on OpenBSD behaves more like Linux relatime. Version 4.0 of the Linux kernel mainline, which was released on April 12, 2015, introduced the new mount option LazyTime. It allows POSIX-style atime updates to be performed in memory and flushed to disk together with some non-time-related I/O operations on the same file. Atime updates are also flushed to disk when some of the sync system calls are executed or before the files in memory inode is evicted from the file system cache. Additionally, it is possible to configure for how long atime modifications can remain unflushed. That way, LazyTime retains POSIX compatibility while offering performance improvements. ctime. It is tempting to believe that ctime originally meant creation time. However, while early Unix did have modification and creation times, the latter was changed to be access time before there was any C structure in which to call anything ctime. The file systems retained just the access time atime and modification time mtime through 6th edition Unix. The ctime timestamp was added in the file system restructuring that occurred with 7th edition Unix, and has always referred to inode change time. It is updated anytime file metadata stored in the inode changes, such as file permissions, file ownership, and creation and deletion of hard links. In some implementations, ctime is affected by renaming a file, both original Unix, which implemented a renaming by making a link updating ctime, and then unlinking the old name updating ctime again, and modern Linux tend to do this. Unlike atime and mtime, ctime cannot be set to an arbitrary value with utime as used by the touch utility, for example. Instead, when utime is used, or for any other change to the inode other than an update to atime caused by AI accessing the file, the ctime value is set to the current time. Time granularity. Time t provides times accurate to 1 second. Some file systems provide finer granularity. Solaris 2.1 introduced a microsecond resolution with UFS in 1992 and a nanosecond resolution with ZFS. In Linux kernels 2.5, 48 and above, the stat structure supports nanosecond resolution for the 3 file timestamp fields. These are exposed as additional fields in the stat structure. The resolution of create time on a FAT file system is 10 milliseconds, while resolution of its write time is 2 seconds, and access time has a resolution of 1 day, thus it acts as the access date. Example: